Hi, everybody. So our first video is going to be on solving systems of equations, which is the last topic we were covering in class before we all dismissed for this very unexpected break. So let's go ahead and get started. What is a system of equations? Do you remember? It's two or more linear equations, for example, y equals 3x plus 1 and y equals negative 1/2 x plus 1. And you're comparing these two linear equations. What are the three solution types to a system of equations? Do you remember that? We've got one solution. What does this look like on the graph of a system? The two lines would intersect at a singular point, and that point or ordered pair is the answer to the system. Our second solution type is no solution. And what does this look like on the graph of a system? Well, the two lines would be parallel or never cross. So since there's no point of intersection, the answer to the system is literally no solution. Our final solution type to a system is infinitely many solutions. Sometimes it's called or referred to as all real numbers. What does this look like on the graph of the system? It's the same line or equation written in two different ways. So there'll be two equivalent equations, and you can think of it as two lines directly on top of each other or just the same line. So every single ordered pair on that line is an answer to the system. Do you remember the three methods we discussed for solving systems of equations? Those three methods included graphing, substitution, and elimination. So these three methods, we took them and discussed them individually, and then we looked at them together cohesively to try and figure out when is each of the methods the most efficient to use. So when graphing is most efficient is when both equations are in slope-intercept form, and we decided that substitution is the best method when one equation's in standard form and the other equation's in slope-intercept form. If you need to go back and review what these forms are, you might pause this video, take a second to go look back at your notes. Elimination is your most efficient method for solving a system when both of the equations are in standard form. Okay, so let's see if you can decide which method would be best for solving this system of equations. Would it be graphing, substitution, or elimination? Graphing is your best option here because both of these equations are in slope-intercept form, y equals mx plus b. Which method would be best to solve this system? Is it graphing, substitution, or elimination? Elimination is your best option for this system because they're both in standard form. And in this instance, since these two coefficients are exactly the same, we're going to subtract the two equations when it's time to solve. Which method would be best to solve this system? Is it graphing, substitution, or elimination? Substitution is your best option here because you've got one equation in standard form and one equation in slope-intercept form. Now, what would it look like to solve each of these systems using their efficient method? So when we solve this system by graphing, we're going to start at our y-intercept, -1, and use our slope to go from there. So when you put these two lines on the graph, the purple line is 3x minus 1, and the black line is 4x. The point at which they cross -1, -4 is the solution to the system. We all were pretty good at graphing. Substitution, we actually ended up liking a lot, despite the fact that a lot of you think it's tedious. So here's our system that we decided was best for substitution. When you substitute, you're going to take one equation and basically put it inside of the other equation. You're taking your equation in slope-intercept form and putting it inside the equation in standard form. And the result is this. You're always going to have this set of parentheses. And then you solve it just like you would any other multi-step equation. We're going to distribute the -6. And here's your result. Remember, be careful with those negatives. So we have 8x plus 12x plus 6 equals 16. So we would combine like terms and subtract 6 from both sides. And finally, divide by our coefficient 20. So my x value is 1/2. That's not my final answer because I need a y value. I need a complete ordered pair, x value and y value. So I'm going to take 1/2 and substitute it into my other equation to figure out the value of y. So the result is y has a value of -2. So my final answer is the ordered pair 1/2, -2. Okay? So what would it look like to solve using elimination method? This is our system. We decided elimination was the best method to use. So when your coefficients are the same, you're going to subtract the two equations, and vice versa. If they are opposites, you're going to add them together. So when we subtract, 3x minus 6x is -3x. 4y, -4y, minus -4y is 0. They cancel out. That's why I've got this line through them here. And then 1 minus -2 is +3. So then we're going to divide by our coefficient of -3, and we have our x value -1. Again, I need a complete ordered pair, x value, y value. So I'm going to take that x value and substitute it back into either of the original equations. It doesn't matter which one. You should still get the same result. So if I choose the first one, I'm replacing x with -1 and solving for y. So add 3 to both sides and divide by your coefficient. So my final answer is the ordered pair -1, -1. Okay? So that's solving systems using each of the 3 methods we covered in class. Okay? The very last thing, or one of the very last things that we did in class, was working on word problems with systems of equations. So you had to take those 3 methods and decide which one to use on a system of equations of your own creation. Okay, so let's walk through a word problem together. Your class of 26 is going on a trip. There are 5 vehicles, vans, and cars. The vans seat 6 people and the cars seat 4 people, including drivers. So how many vans will be driven? The very first thing that you need to do when you're solving a word problem is define your variables. So in this case, we've got vans and cars. So we'll use the variables v and c. Then you need at least 2 equations, 2 separate equations, and you need to look in the word problem for 2 different categories or types or things that are being compared. So in this word problem, we've got vehicles and then we've got people. So we're going to have an equation representing the number of vehicles. Number of vans plus the number of cars is 5. And then an equation representing the number of people. So 6 people per van, in addition to 4 people per car, is going to add up to, or should add up to, our 26 people. So next you would determine which method for solving is most efficient. Since we've got both equations in standard form here, we're going to use elimination. Okay. We're going to use that method to solve for our first variable and then substitute that first variable into one of the original equations to determine the value of the second variable if it's necessary. So let's go ahead and take a look at what it looks like solving this system using elimination. Now, this is a little bit different than our previous example using elimination because you should notice that none of my coefficients for V don't match up in any way, and my coefficients for C don't match up in any way. So what I'm going to have to do is multiply the first equation by either 6 or 4 to get them to match up. In this case, I multiplied by 4. You can multiply by 6 if you prefer. So when I distribute that 4, I get 4V plus 4C equals 20. And I've done nothing to the second equation. It just remains the same. Now, I have to decide if I'm going to add or subtract. My coefficients for C are exactly the same. Same starts with S, so does subtract. So we're going to subtract 4V minus 6V to get negative 2V. 4C minus 4C cancels out, it's 0. 20 minus 26 is negative 6. So we divide by our coefficient, and the result is 3. And this works out nicely because the original question was how many vans were driven. In this case, 3 vans were driven. Let's try another word problem. I'll help you get it set up, and then I'm going to let you solve it on your own. So Mary and Amy had a total of 18 yards of material from which to make costumes. Mary used 3 times more material to make her costume than Amy. How many yards of material did Mary use for her costume? So we define our variables, Mary and Amy. So M, Mary, number of yards she uses, A for Amy, and the number of yards she uses. And then we need to look at our 2 categories. What are our totals that we are comparing? In this case, we know that there's a total of 18 yards of fabric being used. So we know that the number of yards Mary uses plus the number of yards Amy uses should add up to 18. The other piece of information we have is Mary's total. We know that her total is equivalent to 3 times the amount that Amy uses. Okay, which method would be most efficient for solving this system? Hopefully you said substitution. So I'd like for you to use substitution to solve for how many yards of material Mary used. Were you right? Let's walk through how to do it. So we're going to replace M, or Mary, with 3 times Amy. Okay, substitute. Combine like terms and divide by our coefficient. So Amy used 4.5 yards of fabric. We're not done because we need to know how much Mary used. So we're going to take that A and substitute it into our first equation, M equals 3A, to get how many yards Mary used. So hopefully your final answer was the same as mine, 13.5 yards of fabric. Okay, you're probably thinking, this is way too hard on my own. There's no way I'm going to be able to use any of these methods by myself at home. Don't panic. Try downloading the free Desmos Calculator app on your cell phone, or if you like using your laptop, iPad, Chromebook, whatever it is you're using, you can save this link as a bookmark on your desktop, and it takes you to an online calculator. Okay, so this is what it looks like. Now, the only caveat is you can't use any variables other than X and Y. So you're going to have to replace your variables with X and Y. You can't use any other letters than those. So in this case, my letters would go from M and A to X and Y. So X plus Y equals my total yards of 18. And then I had Mary, let's say Mary is X, and she was equal to 3 times Amy. Okay. And you might notice over here, there's only one line. Well, that's okay. We can zoom out and see where the two values intersect. So I have 13 and a half and 4 and a half. You would have to use a little bit of logic, a little bit of understanding to know that since Mary used more fabric, hers is the larger number. It wouldn't make a difference if you transposed the Y and the X, because you're still going to get that same combination of 4 and a half and 13 and a half. It's just Mary is always the larger number. And that's from your understanding of the word problem. Okay? So make sure you give that a try at some point if you're worried about it. Here's a screenshot of what we just took a look at. In this case, I would have X representing Mary and Y representing Amy. Highly recommend you get comfortable using that calculator with Desmos, because that is the one that's used on online math exams in North Carolina. All right, so to quickly summarize this video, we discussed systems. Systems are 2 or more linear equations being compared, all right? And then we looked at our 3 solution types: 1 solution type, no solution, and then all real numbers. And then we looked at our methods for solving: graphing, substitution, and elimination. And finally, we looked at how to use those methods within word problems. And then if you're still concerned about solving them on your own, give technology a shot. Okay? So what do you do next? The next thing you're going to do after completing this video is either join a Google Meet to discuss the video live, or you're going to schedule an appointment with me during office hours if necessary. If you feel like you understand it, you're good to go, then you don't have to do either of these. Regardless, you should complete the Google form on Google Classroom with all the questions for solving systems from the released exam for practice. Once you complete that Google form, if you have any questions, again, you could schedule an appointment with me during office hours. And there's always email, so if you ever have a question, shoot me an email. All right, guys, that's it for now, and I will talk to you soon.